All right, so we're going to go over critical values. And so by the end of this slideshow, you should be able to tell yourself, I can calculate the confidence intervals of intervals other than 95% using critical values. So yesterday we spent our time looking at confidence intervals of 95%. And today we're going to look at how to do it for other critical values. A lot of polling companies do use 95%, but sometimes they use 90%. Sometimes they use a margin of error using 99%. So again, this is pretty important information because like you see confidence intervals everywhere in life. Like they use confidence intervals and literally every single time there's an election coming up. They use confidence intervals on the number of percentage of people who were willing to vote for Mitch McConnell versus the percentage of people willing to vote for Grimes. You see confidence intervals of Obama's approval rating. You see confidence intervals of um, basically everything. So it's really important that we understand that like even though that they say like the mean is 49% and like there's a margin of error of 2%, just because it's 49% doesn't make it 49%. It could be 51% if they have a margin of error of 2%. So they so in fact the true mean could actually be a little bit more than half. So it's really important that we know what confidence intervals are in life as well. So what is a critical value? It is a factor that we use to calculate margin of error. We multiply this factor by our standard error. So we're going to look at a little bit more of what that is. It allows us to So what is the purpose of a critical value? It allows us to calculate confidence intervals that are not 95%. So for example, 90% and 99% confidence intervals. And the formula for critical values is going to be, so we have our p hat, which is again our estimated proportion, plus or minus z with the asterisk, that is our critical value, times our standard error. So literally we're just going to find the standard error, which again for proportions is going to be the square root of pq divided by n. We're going to take that value and then multiply it by the critical value of each interval. Each interval has its own specific critical value, and you'll see how to find that critical value in a bit. So like a 90% has its own critical value, 95% has its own critical value, and the 99% has its own critical value. So how do we find the critical values at certain intervals? So there's a new variable, your alpha or your A. A is going to be equal to 1 minus the confidence interval divided by 100. Your critical you're going to then take that and then you're going to divide it by 2 and subtract it from 1, and that'll give you your critical probability, which is again 1 minus A divided by 2. A again is 1 minus your confidence level divided by 100. And you're going to take what you get, put in your calculator in the inverse norm. You're gonna and then you're gonna find out what the z value is for that. So for example, if I wanted to find the confidence level of 90%, you're going to do A equals 1 minus 90 divided by 100, and that's going to be equal to 0.1. Your critical probability is going to be 1 minus 0.1 divided by 2. That's going to equal 0.95. You plug in 0.95 into inverse norm on your calculator, and you get a critical value of 1.645. So every time you see the confidence level of 90%, you're going to multiply your standard error by 1.645. Really, you mainly see 90% confidence levels, 99% confidence levels, and 95% confidence levels. So it's really important that you at least know those three. But in case you do forget those three, you can just easily use this sort of step by step to figure out the critical values in case you need it. So that's pretty neat in case you ever get stuck. So In April 2011, a Yale/George Mason poll of 1,010 U.S. adults found that 40% of the respondents believe that scientists disagreed about whether global warming exists. They reported a 95% confidence interval with a margin of 3%. Using the critical value of z and the standard error based on the observed proportion, what would be the margin of error for a 90% confidence interval? What would be the margin of error for a 90% confidence interval? What's good and bad about this change? So, what do we need to do first? Well, first we need to calculate the standard error, which is going to be the square root of p, which is 0.4, and q, which is 0.6, all divided by n, which is your 1010, and that'll give us some number, which then we'll square root, and we get 0.0157. Then we're going to multiply our standard error by our critical value. Our critical value, again, from our previous example, was 1.645 for a 90% confidence interval. We're going to do, to find an interval, we're going to do 0.4 minus the critical value of 1.645 times the standard error of 0.015. And then we're going to also take our 0.4 and add the same thing. And we'll get that we are 90% confident that the true proportion of adults who believe that scientists disagree about global warming is between 0.375 and 0.425. So, what are the trade-offs though? Again, we're less confident. We're 90% confident instead of 95% confident, but we do have a smaller interval, which is nice. So again, that's a sort of trade-off. You can have a smaller interval, but you have to be less confident. Like I'm like 100% confident in everybody in this class getting between a 0 and 100. Like I'm like 2,000% confident that that's going to happen. Am I confident that everyone's going to get between that everybody's going to get between 83 and 84? I'm a little less confident because that's a very, 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 very small interval. But yes, pretty exciting stuff. Tomorrow we're just going to keep doing all this stuff. So it's going to be a little bit of practice of the stuff we did the other day, but it's also going to be evolving a little practice of this critical value stuff. So that's pretty fun. Yeah. So I'll see you guys later.